Don't you know that plants like flowers involves math too? Yes, you heard it right. Plant has pattern and those pattern can be observed in the petals of flowers. And so, for today's video, I'm going to show you the different kinds of flowers and their respective patterns.
Fibonacci sequence is a series of numbers in which each number is the sum of the two preceding numbers. The simplest is the series 1 plus 1 equals 2, 1 plus 2 equals 3, 2 plus 3 equals 5, 3 plus 5 equals 8, and so on. The example of this is a sunflower. On the sunflower seed, there is a two-dimensional design that displays the Fibonacci sequence. A sunflower seed has two paratiches, one of which spiral counterclockwise and the other of which spiral clockwise, emerging from its center.
Radial pattern. Radial pattern arranges the specified features spaced along the circumference of a circle. The spacing can be set so you only arrange features along an arc instead of the whole circle. The spacing and angles are set with dimension settings. The example of this is water lily. Water lilies grown in bodies of water with soil or salt on the bottom. Their large leaves and solitary flowers float on the surface of the water. The leaves have veins that form a radial pattern and a notch on one side that keeps the leaf from being a complete circle.
Next is a spiral pattern. A spiral is a curved pattern that focuses on a center point and a series of circular shapes that revolve around it. The reason why plants use a spiral form is that they are constantly trying to grow but stay secure. The example of this is carnation. Carnation is a subtle, balmy, and spicy fragrance, reminiscent of gloves. Border carnations include a range of varieties and hybrids. 30 to 75 cm and 1 to 2.5 feet tall. The flowers, in a wide range of colors, are usually less than 5 cm to 2 inches in diameter and or borne on wiry, stiffly erect stems. Carnation can give its scent naturally, processed in grass. However, its scent is very disappointing as it is far from that of the fresh flower.
Gumamela has a spiral pattern too. Gumamela is a fast-growing evergreen shrub with dark green and glossy leaves with die-cut flowers. The leaves are oval in shape and they measure between 3 inches to 4.2 inches long. The edges of the leaves are often slightly serrated. They arrange themselves in a spiral pattern and alternate around a long stalk.
What is geometric spiral? Geometric spiral in mathematics, a spiral is a curve which emanates from a point, moving farther away as it revolves around the point. Like, for example, the succulent. Succulent form geometric spirals similar to those of sunflowers, pine cones, and noodleless shells. Spiral leaf arrangements funnel rain to roots and keep upper leaves from shading to lower ones. The arrangement of plant leaves along the stem is called phyllotaxis. Mathematically, spiral phyllotaxis follows a Fibonacci sequence, such as 1, 2 equals 2, and 1 plus 2 equals 3, and so on. Each subsequent number is the sum of the two preceding ones.
The first is radio pattern. A radio pattern arranges the specified features space along the circumference of circle. The spacing can be set so you only arrange features along an arc instead of the whole circle. Spacing and angles are set with the mentioned settings. An example of this is dahlia. Dahlia have two bruised roots with the flower side is a composite consisting of central disc and surrounding ray forest. However, this bloom come in a variety of textures and shapes. Some flower types have a rounded or pointed petals, while the pom-pom and ball dahlia have tightly rolled geometric flowers arranged in spiral. This is a really unique and eye-catching to look at. The cactus types have a spiky look due to its rolled petals, while the decorative types have broad, flat petals.
Rose, a Fibonacci spiral pattern used to express love and affection. Rose petals are arranged in a Fibonacci series. This means that petal number 1 and 6 will be in the same vertical imaginary line. The rose curve is frequently described as flower petals arranged around the pool. The petals are all congruent to one another and can have symmetry across the polar axis. This pattern is followed by organic life as it develops and grows. It explains why the densely packed petals of a rose flower or a head of cabbage make mathematical sense. Its natural basis is that each new set of petals grows in the spaces between the previous sets. This makes sense since the upper leaves will not take all the light from the lower.